Welcome back to the ShaderFX Planet Shader tutorial. In this first part of the video, we're going to take a look at adding a second cloud layer and doing some UV animation and distortion on that. So let's jump right in. I have ShaderFX open here. Everything's the same from the last video, and the last thing that we did here was create a group node for our clouds mask. So I'm going to go ahead and open that up, and we're going to get started. So ultimately we're going to have two cloud texture masks, and one's going to have some UV distortion. That'll be the first one that we created here, and then we're going to have another static one that looks like it's kind of underneath this topmost layer of cloud on our planet here. So let's just take this cloud mask texture node here and do a copy and paste, and we'll put that up here. And what we're going to do is we're going to drop down a multiply. So let's just type in our node browser here and bring up a multiply. And we're going to grab the red channel of our cloud mask, and then we're going to drop down a float. Whoops. And we're going to multiply our float times our cloud mask. And I have this value set at 0.1. But we'll name it, and this is just going to be second cloud layer opacity. You can't have any numbers at the beginning of your name here, so I'll just rename that to second cloud layer opacity, and I'm going to expose that as a material input. So we can adjust that inside of the My Attribute editor, and I'm just going to make a UI group called Clouds Attributes. And then at the end of our multiply here, we're just going to drop down in add command, and we're going to add our second cloud layer with our first cloud layer and reconnect that result to the output on the right side of our group node here, and the computer's going to catch up. And one thing that we want to do whenever you're using an add command for texture maps like this, we want to drop down a clamp. So just because our values here are going to be adding this cloud mask with this cloud mask, and that can result with some extra bright white values that are larger than 1. So we're just going to drop down a clamp. So let's type that in. And our result's going to go into the value of the clamp, and we're going to want two float values for our min and max. And our min's going to be 0, and our max is going to be 1. And typically when using a clamp operation like this, what I like to do is just grab these three nodes here and just create a group out of that and reconnect our result to the output of our group. We can exit that group again and just rename this group node to clamp 0 to 1. This is good because if we ever need to clamp something else, we can just copy and paste this group node without having to make all three nodes. So, and then we're just going to grab the result of our clamp and replace that result on the right side of our group node. Now obviously if we were to take a look at our planet, nothing's going to have changed because all we're doing is adding the same cloud mask on top of the other cloud mask. And what we want is to have it kind of moved over to the side a little bit. And what we're going to do there is we're just going to take our UVs and offset them a little bit. So that's pretty simple. We're going to drop down a UV set node. Always forget to add the space there. And what we want to do is add a float integer to our UVs, and essentially that's going to say take the 0 to 1 space and just nudge it over by a float value. So to do this, we'll just drop down an add, and we'll grab a float 2 for the U and V coordinates of our UV set, and just plug that into our add here. And I've found that an X value of 1.25 seems to work. And we're just going to drop that into our cloud mask here. And we should be able to drag ShaderFX off to the side and see now that we have a second cloud layer that's underneath the first one that has, you know, just a little bit of opacity. And we can actually just drag this float value up and let's change to 0.5, and you should now see that we've got a second layer in there. And for me, the 0.1 value looks pretty good, but obviously that's up to you. The last thing that we'll do here between our add operation and the cloud mask is we'll drop down a panner, a UV panner node, just in case we want to animate that that secondary UV. So let's just hook that up. I'm going to grab the results and plug that into the input UV of the UV panner, and just grab that output and plug it into our cloud mask texture here. And I have a U value of -0.001 and a V speed of 0, and that should be pretty good if we bring up our time slider here and we just drag this along. You can see that it's moving in the background a little bit. Let's increase our range here. Let's make it 300, and let's just go ahead and play that. And you can see that it is animating in the background here, and that looks pretty good. So the next thing we're going to do here is animate our second cloud layer and add some distortion to that so that it has some variation in the movement of the clouds. So let's bring up ShaderFX again, and what we're going to do is set up a very simple UV set command for our second cloud mask, and then we're going to create a group out of that, and it'll keep everything really organized. So let's drop down a UV panner and plug that into the result of our cloud mask, and let's go ahead and create a group from that, and we'll just name this Distortion Animation. And let's dive into that group. So now we have our UV panner set up. We're going to drop down a time because we're going to want to adjust the speed of the clouds via the My Attributes window without having ShaderFX open. So let's drop down a time node and a multiply. And let's grab a float value. Just drop that float down, and we'll just rename this float to cloud speed, and for now I'm going to put it at 0.5. I'm going to expose that as material input, and I'm going to change my UI group here to clouds attribute like we've done before, and we'll just hook that up. So time node and the cloud speed float integer goes into the multiply, and we grab that result and plug that into the time of our UV panner. So I'm going to set the speed U of our UV panner here to -0.003 and my V speed to 0 before we move on. And next we're going to set up our UV distortion. Now if you've watched the turbulent fire tutorial videos, this should be pretty simple for you, and if you haven't, I would go ahead and recommend that you watch those because I go kind of in detail about what UV distortion is and how it works. So I'm not going to go into extensive detail about what it's doing here, but I will walk us through the setup. So I'm just going to go into Photoshop and create a noise texture for our distortion. I'm going to make the width 512 and the height 256. The resolution on this doesn't have to be super high res. I'm just going to hit OK, and I'm going to change my foreground and background colors here to black and white. Make sure that my background's selected, and go to Filter, Render, Clouds. And that looks pretty good. Let's just make sure that this is tileable, so we'll go to Filters, Other, and Offset, and just make sure that we've got a tileable texture here. Looks good. And let's save this. So I'm going to save it into my source images folder as noise distortion, noise, and just hit save, hit OK, and we can jump back into my LT. So now we're going to bring our noise texture in, so let's just drop down a texture map and hit the ellipsis and grab our distortion noise that we just made and hit open. And on the left side of this, we're going to want to animate this texture. So I'm just going to drop down a UV panner and plug that into the UV input on our texture map. And the animation is a little bit fast, so what I have set here is a -0.01 and in the U, in the speed U, and then a 0.01 in the speed V, and that seems to work pretty well. And we're going to want to reduce the intensity of this noise texture. If you remember in the fire videos, our texture maps were always a little bit intense, so I recommend doing a multiply by a fraction. So let's do a texture map, and we're going to multiply our color with a float value. So let's just drop down our float, and we'll call this distortion strength. And we'll put that in the UI group clouds attributes and expose that. And for our value here, I have a value of 0.075, and that seems to work well. And let's just plug that in. Next, we're going to create UV coordinates out of our distortion noise texture here. And to do this, we're going to drop down a vector component, because we want to convert our float3 value here to an XY or UV float2 value for our UV coordinates. So I'm just going to grab that result, plug that into our vector component here. So I'm just going to jump over to Photoshop and do a quick refresher on our UV distortion. We have here UVs represented graphically, so I'm just going to jump over to Photoshop really quickly and do a refresher on our UV distortion. Here I have represented graphically our UV coordinates. In the red channel you have the 0 to 1 on the horizontal scale, and then on the vertical scale you also have represented here 0 to 1 coordinates. And essentially what we're going to be doing is taking our noise texture here and adding it on top of this UV coordinate. And what we get is this kind of distorted coordinate system, which will look good for our cloud distortion. I'm just going to jump back to my LT now, and let's go ahead and hook that up. So what we want is our UV set, which is our standard UVs, that 0 to 1 coordinates, and what we want to do is add our distorted UVs here to that UV set. So let's just take the XY output of our vector component here and the UV output of our UV set and add them together. Now if we open up the preview, you should be able to see that you get some distortion in there. If I were to change the opacity here, the strength here, it's back to 1 for example, you'll start to see exactly what we had in Photoshop represented in our shader. So I'm just going to drop that back to 0.075 because we only want a subtle variation, and we can plug that into our UV panner and let my computer catch up, and I can minimize ShaderFX, and if we play we start to get this kind of interesting looking noise distortion to our clouds. Now if we actually close ShaderFX, we should have our cloud attributes exposed. So if I want to, for example, slow down the speed of the clouds, I can change it to maybe 0.25 or something like that. And it looks like our distortion strength is actually in the wrong place. So let's just jump into our group here and make sure that we have that UI group for the distortion strength. So clouds, attributes, just hit enter, and we can close ShaderFX again. And now that's in the correct place, so we can save that and play, and we can adjust our strength. So maybe we want it a little bit less, or maybe we want it a little bit more, so let's try 0.01 or something, and that starts to look pretty cool. We now have 2 layers of clouds going on here. We've got one that's a little bit less opaque and one that's pretty clear on top of that, and it looks cool. So The next thing that we're going to do is set up our city lights on the dark side of the planet. So let's jump back into ShaderFX, and we can exit our group here and exit this group. So our cloud mask is all set up, and the next thing that we want to work on is our city lights. So what I'm going to do is I'm just going to drop down a texture map, and we're going to name this city lights texture, and I'm going to navigate to my night lights and just hit open, and I'm going to go ahead and immediately drop this into a group. So I'm just going to create a group, and I'm going to rename this group to I'm going to have custom lighting city lights, because we're going to have to, in order to get this hooked up, we're going to actually have to go into our surface shader. But let's set up some of the basic stuff first. So let's jump into our group here. And the first thing for our city lights we're going to want is a intensity. So let's just drop down a multiply and grab our color and a float value, and just plug that into the multiply, and we'll rename this city light intensity city, and our UI group is just going to be city lights attributes, and I'll expose that. And now I can hook up that multiply to the output of our node group here. So the next thing that we're going to have to do is somehow extrapolate from our light here, our directional light here, the vector that it's pointing at the mesh here, because essentially we don't want our lights to show up on the lit side of the planet, we want it to show up on the dark side of the planet. So we have to rig up the direction into our shader. So the best way to do this is with a light vector and a dot product. So we can search for a light vector, and the node is right there, so let's just drag and drop that in. And the next thing that we want is a dot product. Now essentially a dot product is going to take two vectors and return a value of 0 or 1, and that's kind of the dot product in a very simple form. There's a lot of information out there if you want to know the mathematics behind it, but essentially for us what we're going to be doing is saying we want a 1 for where the light is hitting the object and a 0 for where the light is not hitting the object, and we're going to dot our normalized light vector with the world normal, which is going to give us that 0 or 1 value. Again, if you want to learn more about the dot product, Wikipedia has a great article on it, but for us essentially it's just going to return a 0 or 1 value. And I'm going to grab the world normal output and plug that into our dot product. And as always with a command like this, we're going to want to do a clamp. So I'm just going to go into our clouds mask and just grab that useful clamp 0 to 1 group and drop that into our custom city lights, and just drag that connection into the clamp group. Now if you want kind of a simple visualization of what's actually happening here, if you just turn off textured mode, this is basically the information that we're gathering. If you look at the light vector here, if I change it around, this value that's being hit right here is 1, and this value being hit right here is 0, and that's kind of the light vector and the world normal represented graphically. So it's a very simple explanation. There's a lot of math that goes behind it, but again, for our purposes, that's all we really need to know. The next thing that we want to do is kind of tighten up. If you look at our shaded mesh here, we kind of have this large fall off. So we actually want to keep that pretty tight for our city lights interpolation. And what we're going to do is just take our dot product here and do a fall off like we've done in the past with a power node. So I'm just going to grab a power operation, drag our clamp into the X value, and we're going to drop down a float and we'll plug that into the y value, and our float here is going to be named, let's call it City Lights Fall Off, and our group is the City Lights attribute, so I'm just going to copy and paste that into the UI group and hit enter. And now the last part of our setup here is we want an interpolation that takes our light vector information here and interpolates between the city lights texture and a value of 0. So essentially it's just going to be like an on-off of our texture map. So let's drop down a linear interpolate, and we want our city lights texture here to go into the first value, and then we're going to just drop down a float 3 with a value of 0, 0, and 0 in the X, Y, and Z, and that will go into the second input on our linear interpolate. And our mix is our light setup here, so I'm just going to drag that into the mix, and I can drag the linear interpolate result into the result on our group, and we can exit the group. And the last thing that we have to do is just move this up to the top where our backside illumination multiply is, and just drop down and add, and we'll just add our city lights to our backside illumination and just drag that into the emissive input on our surface shader. Should be able to drag that out of the way, and you should see on the backside of your shader the city lights texture is now lighting up, and as we rotate our light, the city lights will turn off. Now it looks like I forgot to adjust my fall off, but if we jump back into the group here and we go down to our fall off here, this is what I was talking about. That fall off's the gradient's kind of large, so if we just drop this down to 0.1, that worked for me. That was a good number. Wait for my computer to catch up, and now there's no straggling lights that are happening, and it looks pretty good. Now if you are using MyLT 2014, just plugging that into the emissive may not work. I can't remember exactly which version of Maya was using that it wasn't working properly, but there is a possibility that the emissive input does not take light information. So I'm going to run you through really quickly how to adjust that. If you're running into a problem where it's actually just not showing anything, this should fix the problem. So instead of doing an add operation just like this and going right into the emissive, we're going to actually bypass the entire surface shader and add it separately. So let's go ahead and do that. So whenever you make any edits to the traditional game surface shader, you have to make sure to go to Group and hit the Make Group Unique button, because if you make any edits and you haven't changed that, this will draw directly from your hard drive and it will overwrite any changes that you've made to the surface shader. So just make sure that's on, and now we can open up the surface shader. Essentially what we're going to do is bypass all of the lighting information, all of the shadowing information, and we're just going to add our texture map directly after that. So I'm not going to go over what's going on in here. It's pretty advanced, some interesting stuff though. We're going to dive into the inside light loop group, so just go ahead and open that up, and you're looking for the diffuse spec add operation, and we're just going to drop down an add node. So I'm just going to search for that and add that in, and I'm going to grab the result of that, and unfortunately what we do have to do is drop down a float 3 so we can tell this add operation what to expect. So I'm just going to drag that in, and now that add operation is going to go into the color alpha vector construct here, and just wait for this to catch up. Now we can delete this float 3 that we just dropped down because we're going to be feeding this back through to the main window. So just grab this value and plug it into the NE13 input on our group, and we'll exit the group. And inside the light loop group, we want to just grab the last value here and plug that into the NE16 input on the surface shader here. And now we can actually adjust the name of this. So if you click on the group on the left hand side here, and we just go to active socket 16, we can rename this to City Lights and just hit enter, and now that name will actually be City Lights instead of I think it was value before. Now we can exit the group, and the surface shader is now red because it's expecting an input and it can't do anything without that input. So what we're going to do is just get rid of this add operation for the emissive here, plug our backside illumination back into the emissive, and now we can take our group node here, that's essentially our custom lighting group node, and bring it down to the bottom and plug that into the input on our surface shader, and just wait for everything to catch up, and you should have the same effect. So essentially all we've done is bypassed the shadowing information in our surface shader and hooked our city lights after all of that information. So if that isn't working for you in Maya LT 2014, just doing the add to the emissive, this is a workaround that does work. So I hope you enjoyed that video. We've made a cool little planet shader here that has some interaction with the Maya viewport, and of course you have the extra exposed features here. So if you have any questions, let us know on the forum, and I will see you in the next video. Thanks.